Nu är det dags att dra sig hit mot Innodex och Tech Arena-scenen. Vi har vår första programpunkt för dagen och det är ingen mindre än Sascha Peters som kommer att prata om High Advanced Materials for New Mobility. You're welcome. Go ahead, Sascha.
Yeah, thank you for the introduction and the nice possibility to talk to you. I'm Sascha Peters. I'm setting up these materials exhibitions every year in the Innodex arena. I'm running a future agency in Berlin. That's how we came to do these shows here. Today I would like to talk to you about materials innovation and developments we found especially for the mobility industry. We nowadays see that there's a huge transformation process into electric vehicles, but maybe that's not the end of the story. You know that we in Germany have a lot of car producers, still have this, BMW, Audi, all of these. And most of them are situated in the south and in the southwest of Germany. So there is, it's not, you know that the solution, it's not working. So we brought a car with us. You see that car over there. That's coming from the so-called Innovation Campus New Mobility. This is an initiative of Karlsruhe Institute of Technology, so Karlsruhe University and the University in Stuttgart, where Audi, Porsche and Mercedes are situated around to think about how the future could look like. It's an electric vehicle based on fuel cell. Yeah, okay. Yeah, now you see, it's an electric vehicle based on fuel cell. The fuel cell is there is a hydrogen tank here. This is the heart of the vehicle, the computer calculating the information about the sensors around to finally maybe make autonomous driving possible. It's about lightweight design. It's about how and where to bring carbon fibers into, combine them with natural reinforced materials to reduce the weight. The body only weighs 4 kilograms in that demo car. We also have a seat with us, which they developed for that car, made of natural fibers, hemp fibers in this case. So we have good contacts to these guys. They also, so we got the car from him, Till. We both bring the car into our van last Friday. So this is the project they are working on at Stuttgart University. They are winding carbon fibers around a cardboard core and wash the cardboard out of the winded carbon fibers when it's stiff enough. They wash it out with water. You know that cardboard is getting quite easily to remove out of the mold. So that's a hands-on technology they developed at the university. I told you about hemp fibers, which they use in the seat. Hemp fibers are quite interesting. Nowadays, the European Union allow it to grow hemp fibers, which wasn't allowed some years ago. Hemp fibers are strong and stiff. Hemp is fast growing. They grow it in between August and October, it grows in these 3 months about 3 to 4 meters height, and you can use any part of the plant for different kind of reasons. The fibers you can use in lightweight. There's one company in Leipzig which is producing ski from hemp fibers, and a pallet we have over there. We find a company doing traffic signs from hemp fiber reinforced bioplastics instead of using aluminium for outside use, and they say they can reduce the CO2 emissions by doing so by 99% because it's renewable. And imagine how much energy you have to put into produce aluminium. So minus 99%, that's a high number. And they say that we have a sign over there on display. They say that you can use the sign for about 10 years outside uses in all weather conditions. So one example of how they use the material. We found a guy called Anders Breitholz, who is the founder of Paper Shell in Göteborg, who works with a material based 100% on paper, so cellulose from paper, and press it into a mold to make it super strong and super stiff. We have the board over there and a seat for bicycling. He says the material is 100% coming from wood. It has all the qualities you need for outside and inside use, and they make a deal with Polestar that they are going to bring this kind of material into the car interior within the next years. We found a student, by the way. That's a student project from Lennart Bengel. He is studying in Essen, where he designed a longboard, electric longboard, and put in as much interesting material for mobile aspect as he could. So he works with a balsa carbon structure. He works with a full suspension swing arm, which is 3D printed, by the way, and it's foldable. You can test it over there. We have it with us. It's foldable to make it easy to bring it from one point to another. He put some batteries inside. It's modular. Everything inside what you can imagine to have also in the, for example, in the car industry. That's a 3D printed part in metal. Back to that car. They asked me if I want to have the transparent version or the one with a skin around the carbon structure. I decided just to bring that one because you can easily see through. They are working on a flux rectangular machine. I don't got the story exactly. I asked the guy to tell me in 2 sentences what it's all about. It was a long story. He started to tell me then. He said it's with electric vehicles, in future we will have 4 different motors on the 4 different wheels, and we need to separate the magnetic field from the electric field. And this is possible with this kind of motors they are working on. If I got the whole story. Then they work on additive manufacturing principles to bring into the development of different electric motor components. That's what I would like to show with this image. We bring in bipolar plates for to set up fuel cells. There is a company called Cellform who who invented quite an interesting technology to do so. So we have one of these bipolar plates on display. We also think from our perspective that we will have a hydrogen industry set up in the near future, not only for the mobile industry, but also for these high energy industry production, especially when it comes to steel production or aluminium productions. We need something which is fossil fuel, which is fossil free, and then you're coming to hydrogen, and then how to bring hydrogen from one point to another. You need high pressure tanks. We have one from Hexagon Purus, a Norwegian company on display there, and another one from a research center in Aachen. The difference is that here the matrix is a duroplastic material, which is not possible to bring back into the circle after its product life. In this way, the matrix is thermoplastic, and they work on a process to recycle carbon fiber fossil storage, hydrogen storage in the future. So we have that one on display right over there. Then we brought a bicycle frame with us, where they worked on a battery frame based on natural reinforced material to reduce the weight by 30%, but also to reduce the CO2 emissions. When you work with renewable materials, it's always a reduction in between, let's say, 50 to 90%, depends on the material you use. We find a development from Stora Enso. Sweden is not right, so they are from Finland. We had Otto Kivi on stage 2 days ago, giving us some details about lignode. The material, it's graphite, which is coming from lignin, because lignin is more or less carbon. So at the end, they transform the lignin into graphite to have the material for the anode part. Of course, you still need material like lithium for the cathode, but for the anode, graphite is the right thing to choose. And they have a cooperation with Northvolt in Sweden and with other companies producing battery components. The idea is to find resources which we have in Europe and to be more independent on the resources which normally comes from countries maybe where we have limited access to, like to China. Maybe you have heard about that China limited the export of graphite some weeks ago, and that's not a good sign for the battery industry. We had Vasilka Mandova on stage yesterday and the day before, who is the designer of these two seats we have on display just right at the end of the exhibition. She works for Design Works in California, which belong to the BMW group, and they did two seats concept to give answers to the question of how do the mobility interior fits into the circular economy in future. So we have the technological circle for all the materials that needs a lot of energy to produce, like metals and ceramics, and for all the materials that are synthetic, like plastics, so we need to bring them into the loop. And the other circle is the natural one for all the materials that are natural, that we have to keep natural to bring back into nature. So they work with these two concepts. The technological one is this one, infinite loop it's called, where they reuse materials and recycle materials from other industries, like which they have in the Bay. For example, the surfboard industry is super strong there, so they put on the back, this part, the white part, is made from surfboard waste, from the production waste of these companies. The other seat we brought with is this one. This part, by the way, is made from a bio material which is grown in a lab called Biobucha, the company from New York. Maybe you know the drink kombucha, the tea. There is a mushroom growing on top of the tea. When you take the tea out of the let's say growing box, you throw the mushroom away. They let the mushroom grow in a way that they produce a leather-like material, 100% bio-based and 100% biodegradable. So biocircular, returnable into nature. And BMW asked them if they can use it in the seed industry, which is quite interesting. On the back, yeah, so you don't see it. It's this part is made from. It's called hemp wood. So the hemp story again, a company from Kentucky which produces a hemp-based material which they call hemp wood instead of using any kind of plastics there, and it's super strong. It's 100% bio-based. You can feel it when you and you can touch it when you see the seeds. Yeah, this is the Biobucha laboratory in New York. BMW asked them if they can produce material for them. They say, of course, we can do that. We let the material grow. It takes 2 weeks' time in the lab. And the BMW designers were quite surprised. Oh, only 2 weeks? Normally it takes months to get a new material done for them. So they say, no, we can let it grow. Looks like this a little bit. Biobucha. We had it on display, by the way, last year in our exhibition, these rolls. We still have them. So they are now scaling up production. This is the normal way startup are doing. So this is a rendered image I found on their website. Yeah, I told Vaselka, the lady from DesignWorks, we found a material from a startup in Oslo. Yeah, Oslo, Copenhagen. I don't know exactly how this works together, but they have two laboratories maybe producing a foam based 100% on algae, on seaweed. We have them on display over there, the white material. And this is made for furniture, so seatings. Of course, they can produce something for the car industry as well. I don't know if it's 100% bioreturnable, so biocircular. I don't know, but it's 100% based on algae to no plastic inside, no chemicals. This is also interesting. I don't know if it's usable in everyday life. It comes from designers in the Netherlands, Eindhoven, based a crash helmet which they grew from mushrooms. So they have a mold, they put in also hemp is quite good for this. You don't need to you need to know which mushrooms you take and which food you give them the mushrooms. Then the mushrooms grow mycelium, these little fibers which you normally find in the forest ground. And after 3 or 4 days, you can take the part out of the mold. It's 100% bio, it's 100% biodegradable. It will disappear within some days. Plastic-free, chemical-free, so all in. Now, today, we won't use it outside, but maybe in future. There is, by the way, do-it-yourself instruction in the web. So if anyone is interested in that, you can try. You can buy the mushroom, a mixture between the mushrooms and the food from Ecovative from the US. They also have a company running in Europe. So it's easy to get it from the internet. Then they send you a sack with the mushrooms inside and the food, and you can try. It's really easy. Yeah, we brought crash helmet. We bought a crash helmet from a Fraunhofer Institute. They put in a micro display to give the driver additional information without looking anywhere else. So he's not turning his eyes from the street. This micro display is like, I would say, 3 millimeters wide, and it's energy saving, so high resolution. I don't know if it works with me because I need glasses, so I can't see it. I try to turn it on, and then, oh, is it on or not? I don't know. It's really too hard to imagine for me, but I'm not riding a bicycle, not riding a motorcycle. We have some, they call it reliable muscles on display. It's just behind your backs, working with shape memory alloys. You know shape memory alloys probably from the past. This one which you can bend in a special way, and then you heat them up, and then they are moving back into it, to its original form. It's another idea of application. They had the concept to bring it into the wheel industry, to open and close special geometries with effects to the way a car is moving. We find gear wheels which are 4D printed, because this memory effect you can also find in plastics. And if you print the plastics and the plastics react on heat, you can bring them into a way that they are moving. And when they are moving back and forth, you can start to create a gear movement. So this is what they did. Fraunhofer research project from an institute which is situated near Berlin in Golm. We brought so some pieces from the additive manufacturing part. This is ETH Zurich, where they developed a 3D printed electric motor housing with cooling channels optimized to the way where you need the cooling process done. So this is on display right over there. It's one of the winners of the 3D Pioneers Challenge, where we got the pieces from, and we brought a rocket engine, a 3D printed one, which only could be 3D printed because it's quite a complex lightweight design where you have different parts which are normally coming behind each other, are integrated into one piece. This is for rockets which bring small and medium-sized satellites into space. In future, we will have these ones, and a business is now starting to be around these, let's say, low-engineered satellites to bring into the space. And this is high tech, I know. It's also from a Fraunhofer research center in Dresden in this way. We have a lot. We have about 72 or 74 different ones in Germany. We brought a car door. It's right over there, where Fraunhofer researchers from Darmstadt brought in, they say, they call it vibroacoustic metamaterials to reduce the amount of noise inside the body. So without these ones, you would hear the noise from wind and driving and motor, and with these metamaterials, it's quite less the noise. So they put in these things. It's quite interesting to see the resonators in a regular structure. Yeah, and that's the last one. That's my highlight of the whole show. We brought a fridge. It's on this side, run by magnetic cooling. What is magnetic cooling? Probably you have heard about alloy called Lantal iron silicium. And when you're bringing this alloy into a magnetic field, the temperature drops by 80 degrees without putting any energy into. Of course, you need energy to introduce the magnetic field. They say it's 3 times more efficient than the cooling process we have in the world right now. 3 times more efficient. This is because of the phase transition in the material, right? Of course. So there are some places in the world where they're working on it, and Darmstadt were the fastest. So this is the world's first ever product based on this technology. Yeah, so it works like this, that there is, you have these alloys, and the magnet is turning around, bringing the heat from inside to the outside of the fridge. This is an ordinary fridge. They just follow the movement of the magnet, so it's round shape, quite interesting. But then you ask, okay, it's a fridge, it's for household, but AC, that's another point. Not maybe in our region, but in Southeast Asia and everywhere in the world where you have a lot of heat, you're running AC, so it's a huge amount of energy. They say it's about 8 to 10% of the whole energy we need worldwide is going into cooling processes. So a lot of potential for this. And why do I talk about this in a mobility presentation? We think that there will be an infrastructure for hydrogen in future, or also for mobility solutions. And then there is one step where you have to liquefy hydrogen, and there is no technology in the world right now to do so without putting so much energy into to liquefy the hydrogen. And this magnetic cooling process is now the next step. This is the only solution they can imagine to do so. So they are now in a European project called Highly Call, started this year with a lot of money from the European Commission. I'm very curious how far they will come with this. I love that technology. You can try, and you can see the magnet turning around when you have a closer look to the fridge. Thanks a lot for your interest and your coming. If you have any question now, otherwise, I would like to introduce to the next speaker from Motvion. It's you. I forgot your first name. Pettersson? No.
Jonathan Pettersson.
Jonathan Pettersson.
Yeah.
Yeah. By the way, we had the material you are working with is wood, and
Yep.
we had you on display last year, a piece of wood
Oh,
we
yeah,
got
yeah.
from you. This is a very interesting company, a startup company from Göteborg, right?
Yeah, that's correct.
And as I understood it right, you're setting up towers for wind power plants by using wood instead of, what is it? Steel, concrete, and glass fiber. So all the high energy materials, and you have a renewable one, and it's carbon negative, right?
That's correct.
Very interesting.
Yeah.
Thanks for coming. You have the
Yeah, I have it.
the mic show. Okay.
We're just gonna switch the computer setup here.